What's up, you guys? Matthew here. In this video, let's go ahead and build a minimum viable agent to do something that's actually practical. We're going to search for a job. That's right, Bitcoin has crashed and it's time to work at McDonald's. So let's go ahead and have Claude Code get me a job here. It's a good example. It's not cleaning up your emails or something lame. This is something people actually want to do. So let's go ahead. So this is the prompt. You are an expert Python engineer building a simple job search agent that runs as an agentic loop and uses Python scripts exposed as skills. And basically here's the entire prompt here. And we had GPT do it basically. So I prompted GPT with a lame prompt, had it build me a better prompt, and then put that better prompt inside Claude Code, and I flipped it to plan mode. And now we're gonna we're meta prompting the meta prompt because plan mode is actually another meta prompt, just so you guys know. Anyways, let's go ahead and build this agent. I'm gonna show you guys how it works. The cool thing about this is that we're using the best of both worlds. We're gonna import Python scripts into Claude Code as MD files, as skills, so that we can unhobble our workflow and take advantage of basically Opus 4.6 as a wrapper for our Python workflow. So let's get into it. We're going to wait for the plan to finish here, and we'll be right back. All right, so I took my prompt and went ahead and made a huge plan here to make Python scripts and then import them as MD files so that we can use them as skills right here in Claude Code. So let's approve Claude's plan to start coding, and it's going to start working away right here in this folder, job search agent, and we're going to see it write the code here when it's done. So great news. Let's go ahead and approve it. All right, so the agent went ahead and followed all of those instructions, iterated, and now it has a complete rough draft of a collaborative agent that helps you look for a job. And what we've done here is basically we prompted the agent to write a bunch of Python scripts, but then it also wrote these Markdown files that are basically prompts to run Python scripts. So a Markdown file is basically a prompt, and it can be used as a skill. That is, it can be used from this interface now within the folder that I am currently in. So all of these Markdown files are basically prompts, and we can have a main prompt that refers to the other Markdown files, kind of like a prompt chain. And if this file is a loop that says run these other prompts in a loop, then what we have is a full-fledged agent based on the fact that we can just prompt using Markdown files. And so that's very cool, and we get the best of both worlds because what we're trying to do is write these Python scripts to do the deterministic work and have the prompts in the Markdown files refer to the Python scripts so they can be run through bash commands. So best of both worlds, we get the open-endedness of this harness, basically this wrapper. We're using Opus 4.6 as our wrapper now, but I made one mistake. I made a few mistakes, actually. I had these deterministic scripts running for things that are probably not best to be, I guess, worked that way. So let's say I want to write a cover letter. It's over here like parsing hooks with like all of these, words and specific ways of, writing out a cover letter by extracting terms from the job description and stuff like that. It's not very efficient. It's not something a Python script should do, or it should be deterministic. It's actually something that is better handled by the model itself. But the complication here is I can either juggle between some of these referring to bash commands and some of them actually putting workload onto the model, or I could do it a different way, kind of have a Python script refer to a cheaper model and do this with an LLM command in the Python script. So those are two different options. Let's actually just fix it by saying some of these tasks and skills are best for a model to do, unhobbled, not through a Python script. So that's the prompt I'm going to give it. Let's see if it actually just fixes this and does the thinking for me. I don't want to actually have to specify here. We're vibing, right? So all right, so it went ahead and made those updates, and now it's giving us instructions on how to run it. It basically says point Claude at the main agent MD file. So we can actually just open a new session and say run the main agent MD file. And it should work because it's in the same folder. So anytime I open a new session and basically say that, it should be able to locate the main agent MD file and then start running. There you go. Perfect. So now it should start running the agent loop, and we could see actually how this works. And the main prompt that I gave it was basically to create a collaborative agent that uses Python scripts within MD files to run tasks such as do a job search, write a cover letter, do these different things. And the idea of it being collaborative is that it asks me these different questions, like, would you like to use these different preferences? Let's just use existing. I could fill in my preferences right there. So that's the whole aspect of it being collaborative. And the reason it can be collaborative is because it's taking advantage of its ability to log and record and learn as it goes within those Markdown files. So those Markdown files basically become not just a prompt, but also sticky notes for the agent. So it's basically like notes for the agent to actually refer to. So if you have a bunch of notes hanging around and, reminders, that's more or less how the agent operates with the Markdown file. So let's go ahead and just see what's going on. We're having some sort of errors here. Isn't getting bad. It's troubleshooting as it's trying to actually do this thing here. Sometimes just to get it going, you have to kind of work with it a little bit when you're running it for the first time. But okay, it looks like it's actually running now. And if you don't want to always have to actually click approve a bunch of times, because I have it on ask permissions, that might be kind of annoying. You can select bypass permissions, and now it's just going to keep going without annoying you. But mind you, if you're doing something that's dangerous that might end up like basically running a command that you don't expect, then you probably want to monitor it. Okay, so here it's asking me a question. Which jobs would you like me to generate a tailored resume and cover letter for? Let's just pick one of these, I guess. We'll just do 2 of them. All right. And so now it's using all of these skills. So it has a skill for, I guess, a cover letter. And before, it used to be a skill that referred to a Python script to run as a bash command. But now it's only doing the Python script to search for the jobs through APIs. Whereas for the cover letter, it's using this prompt within the Markdown file to just use the model to write the cover letter. So Opus 4.6 is writing the cover letter for me now, whereas Opus 4.6 didn't use its web search to search for the job. It actually just ran a Python script. And that's basically, you want to pick what is best for the model to handle through just a prompt in a Markdown file, or what is best for a Python script to handle through an API. They can still be done through a Markdown file, just in reference to a bash command for the Python script. So that's basically how you build an agent. And now we have this collaborative agent running. And even while it's thinking, let's say I have an idea for it to improve. And just like say, now let's add a way to submit, the resumes. And we can just start building it from the front end. So this now becomes our front end for interacting with the agent loop. But then even while we're in mid loop, we can give it a prompt. Notice it's not loading the prompt yet because it's probably still within the loop. But once it exits the loop, it'll acknowledge the prompt and then start working away at improvements, meaning that it basically becomes like a touch point for the front end and a touch point to build the back end. So it's a wrapper in 2 different respects. It's a wrapper that helps you, I guess, build. It's a wrapper that helps you also use what you built, because you're now using this interface for the loop and using this interface to change things. So it went ahead and I think it's finishing out the loop, and then you'll see here shortly it should acknowledge what I wrote. Just to show you that it basically follows different things here. Run the main agent. It hasn't acknowledged that yet. I guess we'll just pause it. We'll come back in a second. Okay, so here it goes. It looks like I did a typo. So now it acknowledged what I said there. What do you mean by submit the resumes? Where should they be submitted to? Right. So it's like you might need to clarify things. It's like we need to go from job search to job application somehow, right? So it's like, you just clarify. You don't need to be too specific. The agent's pretty smart and it learns as it goes. You can build as you go. You can just give it notes as you go and just be like forget that. Forget that. Just basically, what do I want to do? Take a note that I want to search for McDonald's jobs now only. So midstream, you can start building. Midstream, you can start asking it to take notes. You can say, forget that. You can interrupt it. It'll finish out what it's doing and then acknowledge what you interrupted it for. And that's what the benefit of using this interface, basically Claude code inside the Claude application on Windows. You use this interface as a wrapper for your agent that you build, again, as Python scripts that are referenced inside Markdown files that are referenced as an agent loop in a main Markdown file. And you just built yourself an agent from scratch using Claude code. And it's very cool. I've built different agents like this just as like a test. You can see here, let's just close out this. Forget that, just take notes. So it says, got it. Dropping the submit feature plan. Let's save the note and get you searching for McDonald's jobs. So you see how interactive it is? That's the benefit of this wrapper. And so I have built other agents. Let's just close this out. You can build anything you want. So let's go ahead and I went ahead and built agent 0. Let's say run the agent loop, and it should know what I'm talking about here. Now it's going to run an agent loop that's operating out of this new folder, and that's attached to actually a GitHub that I'm working through. And so now it's starting an autonomous research loop, basically to research new tokens on Solana, using different APIs and using a lot of infrastructure that I already had here in this folder here. I already have a lot of different Markdown files that I already have here. So if I just go to the .claude that I made, you can see it's a research loop that refers to research strategy, that refers to a way to scan tokens and a way to gather tokens. So it can gather tokens, scan them. It has a strategy about how to select them and a loop that kind of runs all of that. And so let's see, we're on loop 61. So it's picking up where it actually left off last night, which is very cool. We have 305 tokens tracked, 7 watching, so it's pretty picky. And then 19 that have been researched. So it doesn't even research a lot of them. It kind of just watches the market and waits for volume. It doesn't really make a move unless it thinks it's worth its time to start focusing in on this one token and then run a deep research. And so you might ask, like on the back end, you might not see what's happening, but I made a front end so that it's kind of easier to see. So this is a scanner that is kind of the same thing that is happening on the back end represented through a front end for a human. So my agent uses this same tool here. It's kind of like a narrow swarm for researching tokens. So it runs a massive script, a huge prompt chain to do all of these different agentic web search. So agentic magic is afoot. Basically searches Twitter. It gets the description, the website from the token, searches the website, tries to find the documentation, searches Twitter for the contract address, searches Twitter for the symbol for the top posts and the most recent posts. If there's a Twitter post that's mentioned or linked to as the website or Twitter link in the metadata for like a pump fund token, then it'll go ahead and scrape the main post and see what the text is, or scrape the main profile, see what the most recent posts are, or even the X community to see the most recent posts. So it does a bunch of stuff on the back end. This may be way too much voodoo for our intended purposes. And so it might take a while. This has been like a minute, but that's how long it takes to just to research one token. And that's what it's doing for like 3 tokens at a time. And so here it's in phase 4, kind of scanning candidates. And it's kind of basically going to build a thesis based on a lot of context that if this closes out, will show you kind of what the context is, the full context that it's given when it's actually doing this whole entire process. So hopefully this finishes soon. Sometimes this takes a while. It can take like 2 minutes because it's doing a lot on the back end. But I like this because it's actually doing a lot of the work that I would do. It's going ahead and researching the tokens and actually interpreting the context and, searching all of that, the things that I would do normally from an interface, a dashboard where I have to click on a bunch of links, read it myself. This actually does all that for me. And it does so in a way that I think is actually high leverage. So the fact that I can use it in a collaborative way and kind of give it feedback and train it as it goes and say like, no, don't focus on this, focus on that instead. And it just writes it as a note in the Markdown file. That's really cool because it's kind of like training a human employee in that way. But eventually you start to hit limits, and this ultimately just becomes a minimum viable agent. It's not a fully fledged agent. So let me be clear about that. It doesn't have like massive memory or massive persistent memory. Those Markdown files are more or less sticky notes that are its memory. So it's kind of like, memory light. It's not very robust in terms of that, but memory is a problem, and it's things that you can basically solve for in different ways. You can build more efficiently for that, but the way I'm teaching people how to build is how you do that. That's how you do that. When you write the Markdown files that refer to Python scripts that leverage a giant world model such as APIs and stuff and inject that as context, it's kind of like deterministic RAG. RAG is like retrieval augmented generation. So that means you're retrieving something from the external world, injecting it into a prompt and then working that within your model. And that's what you're doing if you have a Python script that's fetching real world stuff oriented within a Markdown file within a prompt used by a wrapper here. You're getting all of that. You are getting that. But you're basically solving for the problem I'm telling you exists, the memory problem, through a world model that is external to the model. You're not putting a bunch of stuff on the model. The model doesn't even need to have memory. It just needs to have sticky notes that it reads because it's an amnesiac. It gets born into a new session. It picked up where it left off. It didn't need to remember. It doesn't have memory that it was on, loop 61. And, it referred to its sticky notes and then picked up where it left off using its standard operating procedure in its sticky notes. So that's like how to build long-running agents, because you can't just fill up its memory and then it gets full and then it gets stupid. You just have it have static notes in a world model that lives outside itself that it can pull into context only when it needs to. So it's like it's just pretty good lessons there. I hope I've rambled enough for this to actually be done yet. If it's not, I'm going to cry. All right. It looks like it's actually loading here. So this is the full context that it's given from any given token. It's given all of this different context. So that's pretty cool. And what we're going to do here, improve this agent and get it so that it's actually does autonomous buying. I think there are a lot of LARP projects out there that don't actually have like bona fide research. And if you go to see the front end for the agent, this is the agent research desk, basically a front end representation of all of the data that the agent has to comb through. And you can see there's a lot of data that's available to it. When you click on any one of these given tokens, it will load the full context that it has for all of these different tokens. You can see it has the community posts, the top searches for Twitter, the web search results, the TA. I even have like a cipher indicator here for any token. Basically, it's like normally you'd have to have this inside what's it called? What is that? Trading view in order to get these TA things. So building massive apps like this as front ends are nice for humans, but then it helps you understand what an agent can use within all of your JSON files, because a front end is basically displaying a bunch of data from like a JSON file. So the main JSON file for the front end is like right here. It's like the research desk. So what you're dealing with is basically a huge backend JSON log with a bunch of data that's displayed on the front end for humans. But those same JSONs can be read by an AI. And so when these do the searches, they're just generating the JSONs on the fly and reading the JSON. So you don't need a human to run a search with a software by plugging a contract address into this front end and then read it as a human. You just have the AI do that programmatically and interpret it and only tell you when it finds something worthwhile based on notes that you give it, such as if you find a token where it's a ticker that happens to be contained in a post that Trump made, then you just buy it, right? So that's it's like stuff like that. You can train it to do very unique things without having to write a Python script for it. And that's where you get the full benefits of like a model. So if I wanted to write a deterministic Python script to do something as specific as buy a token that was, happens to have a ticker in it in a Trump tweet, that's very specific, and I have to write that in a script. Or I could just tell an agent in a Markdown file, oh, if you happen to see that, definitely consider that, and it'll take that into account, and you didn't even need to write a script for it. So that's pretty cool. Some things you're better off writing a script for, other things you're better off having the model do. So it kind of becomes a preference, and keep in mind, if you're leaving it up to the model, it may or may not do that when you want it to do it. So there's a problem there. Anyways, what is this actually doing? Oh, so it's just running a loop. So it's dismissed that. Okay, so it's doing proper research. Here's findings. A tier, 86-year-old widow, GoFundMe charity angel. What is this? Researched? What token is this? Is the name of the token researched? Oh, it's called widow. Elaine Dorland. Okay. So it likes that one. You see how it has a bunch of data? It actually has the market cap and knows the bundles and the insiders. Pretty cool. Anyways, I'll see you guys in the next video. I'll show you guys kind of how to improve these agents and how to make them from a minimum viable agent to like an actually a good agent, a persistent agent.